Another draft science video presentation. I hate to say it, but it's almost a video just to this Mesokosmos sky. But you can listen if you want. It just, I don't know, in a way it just illustrates that there's just, there's just so little hope for communication with humans. I mean, I just don't know how I could make things any clearer. And this guy isn't stupid. And he's just making a mess out of it. And I don't know why. I just can't understand why he's doing this. It's so unnecessary. So I've already provided a simple way of deducing what the single slit or the double slit experiment actually does. And the simple logic I've provided is that you have 2 points. The surfaces are the point sources. They're causing all of the fringe pattern. It's all related to events that take place on these surfaces, and essentially it's just scatter and the reconstruction of photons. And I made that clear. And, sorry, can't quite see, can you? And so I've made this point that an really easy way to understand how this pattern is going to be moved around and what it's going to look like is to understand that there's a certain number of frequencies that will fit in this distance, and that number correlates to the points where you can have constructive and destructive events, we'll call them. Events where a photon is remade and an event where a photon won't be remade. And it's just count how many frequencies are in here, and that's it. So this is a distance, d. It's commonly called a, okay, in physics vernacular. And this distance to the target is called L. And it's, a pretty simple equation, and there shouldn't be any complications. This shouldn't confuse anyone. There's just 2 variables plus the wavelength of the light. So, so the simple point I've made is that you just take the wavelength, and let's say it's 500 nanometers, you just divide it into this distance. It'll tell you exactly how many there are, and that length is essentially all you're adding to 2 lines. One line will go from here to here, like at 90 degrees. The 2 lines are right on top of each other, so you can get it that one line is going to be this length from this point to the, let's call it an arbitrary L endpoint, and this line will be longer by exactly the opening of the slit. So it's really simple. We know what this one has to be. Okay, so if it's a whole number, like 16, let's say, everything's going to work out fine, because we know this, at 90 degrees, we know that's constructive. And if it's 15, then we know it's destructive. No, I mean, if it's 15.5, we know it's destructive. So it's not going to be complicated at all right here. And once we have that node, once we know this one is here, we know all the others are the same size, and you just go around the curve, and you'll know what's here, and you're going to know what's here, and you're going to know what's here. You know what's everywhere, because this is this. It's just bigger. It's just this bigger. I mean, why are you making this more complicated? Why are you forcing it to fit your model of, let's do sine theta crap and cosines and all that? Why bother with any of that stuff? Why worry about what angle it is? Doesn't matter. We already know what size it's going to be. And if we know what size it's going to be, we just add them up. Okay? No problem. We know this line is a certain length, this circumference. So what's the issue? And again, these points are so tiny, the distance between them relative to this L length, that even though this is a little bit of a oblong circle, it's not a perfect circle. It won't matter. It's such a tiny error. But anyway, so I'll read his crap, and I'll redraw this over and over again and say, why are you screwing with this? I mean, why are you forcing it to be more complicated than it is? I don't understand. Okay. so he repeats what I said. The single slit math models two vectors with point sources at the surfaces. What you should say here is, yes, that's absolutely correct. Because it's absolutely correct. That's what the model's doing. You're using vectors to define, to illustrate, not necessarily an actual path taken, but the actual consequence. The math will tell you the answer. All right, let's take position 1 as a geometric starting point and calculate the path length difference. Your way. Let's not calculate the easy way. Let's do it some complicated way. That's what you're saying to me, right? So instead of doing it my easy way, okay, which will tell me exactly where every node is and exactly how big it is, you want to do it some complicated way. Why? Why don't you just do it my way? Why don't you just concede my way gets the right answer, so why are you messing with it? Why are you forcing it to do something different? Anyway, based on two vectors A and B drawn from the edges, surfaces. So far, so good. Vectors from the surfaces of the slit. Say edges are point A and B in axis where y is 0. Why is he even bringing up y? There's no y. There's no other dimensions involved here. Anyway, the width of the slit is taken as a distance from the go to point A and B. So this part, I'm just like, why are you doing this? They don't do it in their math. Professor Lewin doesn't sit there and say, you know, I'm going to make a variable, okay, called the distance between the slits or something like that. I mean, here we have the slits, okay, and I'll say it. I mean, 99% of the videos I've seen, I can't even recall any video that does it any other way. They just call this a distance. This. And like I said, sometimes they use the letter A for whatever dumb reason. Or D. Okay? Distance, D, equals some number of meters. You know, 0.001. That's it. Now, why do this? So he has point A and point B, and he's saying I should create this arbitrary bullshit spot in the middle, and then I should say this is the distance, and then I should say there's two D's. Why would I want to do that? I'm just making it complicated. What are you doing this 2D thing? You're just making it look more complicated. Even their shitty math just has one D in it. They don't bother making two D's. They don't bother throwing some other variable in here to make things even more complicated. So I don't understand your intent here. Make the math more complicated for no good reason. I can't imagine any good reason. All right, vectors meet at point C. So that's all we're always saying here is we're going to have a vector from here and a vector from here, and we're going to meet at point C. Well, point C is already defined as a place. It's L distance away. L. That's what the distance of the target distance, that's what it's for. That's why the target has to be a curved line. It's because L has to always be the same. For every node L, for every set of lines you're going to draw from A and B, L has to always be the same. L always has to be the same number. L always has to be the same number. If you change the number, then you're going to have, say, well, I'll predict the second node, the second maxima at L distance, and then I'll predict the second maxima at double L. Nobody's done that in the history of me watching videos of math being done. Nobody's ever done that. Nobody said, I'm going to predict the pattern here, you know, in this one little spot, and then I'll predict the pattern over here. No one's ever done that. So what the hell? What did anyway. Okay. Two vectors meet at C. So he's calling it C, but he's not saying that C point is L distance away from the ergo. PLD is relative to the slit width D. D isn't the slit width. You just said 2D. D isn't the slit width. You said D is the origo to point A and B. You said the slit width is 2D. You say it right here, relative to the slit width, D. Right here you say, so the slit width is 2D. You see how this, you're not helping? Because frankly, that's pretty confusing. I mean, I don't think you meant to say that, but I don't know. Doesn't make any sense. And the position, I mean, really, he wrote a lot of stuff. I really appreciate he's participating and all that kind of crap, but I just don't understand this edit. I don't understand it as a critique or an edit or an improvement or anything. I don't understand its value. Why are you forcing what I'm saying to be what they're saying? I'm not saying what they're saying. I'm not approaching it the way they approach it. Anyway, relative to the slit width D and the position at point C in the following way. Applying Pythagorean theorem, PLD equals square root of C something x divided by D times 2. I don't know. Square root of CD. I understand side angle side. I know some of this Pythagorean stuff. Okay, you could square this side and square this side. Now I'll tell you this side is squared. The hypotenuse. I mean, you can do that kind of crap. But why do I need to do any of that? I've already explained it to you numerous times. I don't need to do any of that because I know L is a radius. I should just get to the part where he's confused. He doesn't know what a radius is. He doesn't know that you're predicting the pattern at a consistent distance from the target. The target's a consistent distance from these things. And if you change the distance, you change the triangles entirely. You change the angles entirely. To get to this point C, or to this one, this is two different angles. You can see that those are different angles, right? This can't be the same thing. You can't do that math in the same. You can't. They're not the same thing. Anyway, I just don't know why you're screwing this up. All right, so I don't know. I don't see any value in any of that crap. The simple argument is the distance L is a radius. All right. The number of wavelengths here will be duplicated on here as constructive and destructive interference points. They will be the same size, and this one you know for sure, so go with it, and it'll tell you all the rest. This distance, the distance of this line, the circumference line, is just L, okay, times pi. That equals this length of this line. And once you know the length of this line, you just do this line as a percentage, okay, as a ratio of this distance. So this distance to the number of nodes is the same as this distance to the number of nodes. Those two relationships are the same. So you just do a proportionality. And it'll tell you exactly if what this size, how much bigger the nodes are here than the nodes are big here. What's the size of a wavelength here is all you're really asking. How much bigger did I make 500 nanometers? 500 nanometers has a certain size here. What size does it have here? That's the question you want to answer. And you don't need to do this sine theta crisscrossy bullshit to figure it out. Alright, anyway. So again, he repeats what I say without any, I don't know what this means. Frankly, I don't know why he's even bothering duplicating what I wrote when he's not interpreting as I wrote it. Okay. The math predicts models. Okay, so that's a statement. The math predicts, and the math is a model. That's what math is for, is to model something in abstractions that correlate to the reality. Models a result on a curved surface of radius L. Target distance. That's the distance from the target. From the source to the target is a distance. That's L. Every bit of what you're attempting to figure out will be on that L radius. Okay, so he says, what do you mean by math predicts the result on a curved surface? What I mean is that when they multiply their product, their sine theta, stuff, times L, okay, that's what they're doing. Okay, they're multiplying the product of their equation, their angle, and they're saying, what's the length of the line difference, okay, compared to L. L is the control line, and you're really asking, at what angle do I create another line that's exactly a wavelength longer? That's all you're really asking. Or a wavelength shorter, or 2 wavelengths shorter, or 3 wavelengths shorter. So I'm saying, you're basically saying what fraction, what period of a wave, what point on that wave do you have a whole wavelength of difference? And there's only certain answers, and that's why you either get a whole number 1 as an answer, and blah blah blah. But again, why do I need to do any of that? When if I know this node and I know the length of this line, I'm done. All right. So what do you mean by the math predicts? What I'm saying is their mathematics uses one L number. It doesn't change the L number. The distance for every set of vectors has to be the same distance away. So it has to be on a curved line. That's what I'm saying. I don't know how you can't get that. I don't know. I just don't know what's missing that this could escape you somehow. That when you put the L in the equation, when you sit there and you start, you're going to do a single slit analysis. And you're saying, well, what's the relevant variables? Okay, wavelength of the light. All right, this thing here, distance. That's a real thing. That's a okay, D. And what's the other variable that matters? Oh, how far away the target is. And so that's L. So those are your variables. Now, if I'm going to do a number of these sets and say, well, I want to know at this location, or I want to know at this location, that location has to be L away. It can't be L plus 7. It can be, but the point is no one would ever do it that way because they want to know the equal, pattern. The pattern is going to be the same size. This, if I change L, I'll change the proportionality of all these things, and none of them will be related to each other anymore. I can't change L, just like I can't just arbitrarily change D. If I change the distance between the slits, so I can't do 2 vectors with the distance being 10, and then I'll say, well, let's just change that to 15 now, and let's do 2 more vectors. They won't relate to each other anymore. They're not connected. The L has to be the same distance from the target. It has to be L here, L here, L, L, L. It can only be L, 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 L. It all has to be on this L line. You can't put it on here and go, L is this. That's not L. This isn't L. Infinite over there to here isn't L. How can you not get that? Sorry, I just, whatever. Have you provided that math in the form of equations somewhere? No, that's the math they do all the time. I'm not trying to duplicate their math. I'm telling you, all we want to know is the answer to the question, what will it be at certain locations? I'm telling you, I can tell you what it'll be at any location, but if I'm going to do all the nodes for a location, I have to do all of them. I can't, if I'm going to tell you, if I'm going to tell you, okay, you give me a slit, any slit, and I'll tell you anything you want to know. You want to know what it is here, I'll tell you. You want to know what it is here, I'll tell you. You want to know what it is here, I'll tell you. But the only way I'm going to tell you is because for any one of those locations, I'm going to create a radius, and I'm going to create an arc. So if you want to know this one, it's going to be on my arc. And if you want to know this one, it's going to be because I'm going to make an arc. And the arc is going to tell me what it's going to be. So I'm going to know all of those locations. So when I find out what it is here, I'm going to find out what it is here, 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 here. On every point on this line, I'm also going to find out all of those answers. So the minute I find one of them, I have all of them. Okay? But I can tell you any one. You can give me any location and I'll find it. But when I find it, I'm going to find everything on that line. So I'll give you all those answers if you want them. Because that'll be a consequence, a freebie. But I can't tell you if you tell me all I can do is this one, and I can't use any other. I don't know what the standard would be. I'm just saying, when I find this one, I'm going to find it with a certain math. I'm going to use completely different numbers for this one. I'm going to use completely different numbers for this one, because it's a completely different experiment. You don't get that? I can't use, I can't use the same parameter of L, okay? I have to use the parameter that you're providing. The location is telling me what the L will be. This L is a number. I can't, I have to use that number to find everything on this L distance. I can't do the same L and tell you what this one is with this L. This L won't tell you what this one is with this giant different L. Anyway, I just can't believe he says, what do you mean by math predicts results on a curved surface? I can't believe I have to go over that again. Have you provided that math in the form of equations somewhere? Again, I've already been over this so many times. This equation is so frickin' simple. You want to know the length of this circumference, you just multiply L times pi. Now I know exactly how long that arc is. That arc will have exactly as many nodes in it as wavelengths. So I just divide it by the number of wavelengths that fit in the distance. So I divide the distance by the wavelength. That tells me how many are in here. And once I know the length of this line, then I just divide the product of this, I just divide that into my L times pi number. So I take this product and divide it into L times, pi. Just divide it into L times pi. So this, like I said, let's do an example. So this is, let's say I divide the wavelength into the distance. It come out to be 30. Okay, then I just take 30, divide it into L times pi. That tells me exactly how big each node is. Now I can just figure out what the node is here, and then I can just calculate what I'm starting with. So 30 would happen to be a whole number, right? 30.0, so we'll make it clear. 30.0. So I know this is the 30.0 point. I know this is the center of a maxima. Okay, I know the node side is 15 divided into this. That told me how big the nodes are. So whatever that number would be, that's how big the node is. And I know half the node is going below the surface, obviously. And so now I know where all the other nodes are, and I just add the numbers up to find any one of these. That's the math. All right. Equation similar. To my knowledge and understanding, path length difference can be calculated to any surface and any distance from the slit. Yes, but not using the same L. Okay, where surfaces curved are flat. The argument is that if you're going to do numerous vectors, if you want to know what the first maxima is and the second maxima and the third maxima of the same relationship, then you have to do it on a curved surface. The L has to stay the same. I just don't understand how you can't get this. I really can't. But anyway, tilted or straight. Why would the photon reconstruction and phase oscillation, so it just almost made me want to puke a little. Phase oscillation. You're still using this pukey little wave rhetoric. I've made it clear to you this is a frequency. You don't call bullets flying through the air phase oscillation. I mean, yuck. Stop at the distance of radius L. It does, of course, it doesn't stop. It goes everywhere. It's happening here, it's happening here, it's happening here. Everywhere I go, I'm going to, any place I put a screen, I'm going to do a calculation. The piece of material will do the calculation. It'll say, am I getting pieces from here and am I getting pieces from here? Are they in phase? Then I'll make a photon. If they're not in phase, there's no photon. Yeah, it's at any single location. So I can tell you single locations. I'm just saying single locations aren't going to tell you the size of the node. So if you want to know the size of the node, frankly, you have to establish a distance. All right, apparently we can calculate the whole number. Again, you wouldn't know which way the node was going, right? I mean, the fact is the node is on a curved space, and so you're not going to have the node configured in the right orientation unless you recognize the node is curved. The node isn't flat screen. All right, apparently we can calculate the whole number coefficient path length different wavelength lambda, which gives us the phase. So again, this obsession, it either is a path length difference, a whole number path length difference, or is not. So I mean, it's not that complicated. You either have restored the frequency or you didn't restore the frequency. All right, to any direction and distance above the slit's walls to be precise. I don't even know what that means, above the slit walls to be precise. I don't know what that. Moreover, we can see that the diffraction pattern, so you're just using all kinds of words here. What's a diffraction pattern? What the fuck is that? I'm sorry, what's a diffraction pattern? There's no such fucking thing as a diffraction pattern. There really isn't. You either have construction and deconstruction. You either have them back in phase or they're not in phase. There's no diffraction pattern. It's also visible on the flat screen. It's not about whether something's visible, it's whether you're going to accurately identify its size. And the point is, there's nothing in the math that's compensating for the fact that your flat screen is creating all kinds of L's. There's no consistent L on a flat screen. Where's your consistency? You have no consistency. How the fuck can you tell me what's going to happen on a flat screen when you can't even make the node? The node is made of numerous little pieces. You do understand that, right? That if there's a bright spot, the bright spot's made out of elements inside of it, little pieces. Those little pieces won't even know where to be if you don't have L being the same number. Each piece has to be L. Each little piece has to be L, L, L distance, L distance, L distance, or you can't even draw your node. There's no math. There's no triangle, okay, that already figured out it was a flat screen. And you can see right there what happens on a flat screen. Well, my node is this big. In reality, when L is always the same distance, that's the angle of my node. If I put it on a flat screen, you can just see it's going to project it over here. And now all of a sudden I'm going to say it's this big. Is it really that big? Or is this the right answer? Which one's the right answer? This distortion or this reality? Which one obeyed the rule? Which one, when I drew the node, which one has L, 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 L distance for all the elements of the node? Oh, that's right, this one does. This one does not. This one has L. Now this is L plus something. This is L plus. This is L plus. This is L plus. Plus a lot here. I don't know. Moreover, we can see that the diffraction pattern, diffraction, is also visible enough so we can know that the diffracted light, so just more terminology, you can't mean it. What do you mean by diffracted light? We're talking about an interference pattern. We already know the light is spreading, okay? We know I'm obviously arguing it's scatter, so what are we even talking about diffracted light for? All right, is visible at longer distances than a radius. And again, it's not about whether it's visible. I said right in this sentence, you don't even read what I write. The math predicts. You can't change L to describe one node. You can't tell me I'm going to describe all the photons in that node, okay, by using different L's. You can't do that. Thus, we can also have a math equation that calculates phase on a flat surface. I didn't say you couldn't have it. You can understand what the relationship is between distance and the fact that you're going to start making infinitely large nodes. Well, the last node will be infinitely large. But you're going to make preposterously huge ones as you go further and further. As your angle gets bigger and bigger, you go to 60 and 70 degrees. Your angle is going to start creating monstrous nodes. And yes, maybe you can create a formula for that predicts it, but that's a lot of added math. I'm talking about the single slit math they use all the fucking time, retard. Sorry. But I mean, clearly I'm not talking about math that does some extraordinary new thing to compensate for this and to compensate for that. I'm not talking about something you can do. I'm talking about what they do. And their math is wrong, clearly, because it's changing the L number. They're clearly using the math with the same L number. Clearly, that's not what you're going to see on a flat screen. Anyway, I don't know how to... I don't know how you can miss in this. Thus, we can also have a math equation that creates phase on a flat surface, only if you compensate for the distortion you're creating. So yeah, they can make an algorithm that can fix a video file that you've overspread on a wide screen. But why would we do that when we could just watch the on a curved screen and not have any distortion? Why don't we just watch it on a curved screen? So I don't understand that which math predicts curved surfaces. So again, I'm just saying the math they're using is not compensating for distortion on a flat screen. It's using one L number. It doesn't change the L number. The L number doesn't go L plus something, L plus something, L plus a factor, L plus a factor. It's one L number. So when they predict it here and over here and over here and over here, all of those predictions are the same L distance from some center. They can't be any other distance from the center, from the origin. Shit. However, the truth turns out that the spherical screen math is a bit more beautiful. Oh, no, maybe we're still up here. I don't know. Okay, now we're down here. However, it turns out that the spherical screen math is a bit more beautiful. You can do the math where they recognize that this is an arc, and they actually do it on 360 degrees, and they cut it, but whatever, it doesn't matter. There's different ways they do it. But clearly what I'm arguing is they always do it the complicated way, because they're always trying to do phase angles, and you don't need to do any of that. You don't need to do any sine theta horse shit. You can do it really simple. All right. So to say, let us use it in the following parts. I don't know. No. Yeah, that's what I'll say to that. But let's see what happens here. So now he says 3, maxima and minima. So he's made new categories now. So he copies what I say, argues with it, and then he uses it, and then he doesn't use it. So this is all very useless as a, you know. I tend to not want to use the words maxima and minima. That's why I'm using the word nodes. Because they're clearly just on nodes and off nodes. On nodes and off nodes. Let the wavelength be lambda and the distance 2d. So again with this 2d horse shit. So just make it confusing for no good reason. So when he's saying 2d, he's really meaning 1d. The distance between the surfaces. Why fuck it up? There would be a maxima of nodes in the circle surface according to floor. So I don't know what that means. According to floor. 2d divided by lambda. So if you're dividing the distance by the wavelength, it's just telling you how many nodes there are. And if you don't have a whole number, then you know the node at 90 degrees isn't an on, which is the phase max. So again, you're still talking as if I haven't already explained this thing 5 million times. I mean, you know, just how you know, you just, like I said, you're smart people. I just don't get it. I just don't fucking goddamn get it. That you're talking again. So phase max means some sort. Max means this thing in the middle, no doubt. Right. I guess that's what it means. What else could that fucking goddamn pile of shit mean? Phase max. The phase index number, i.e. the whole number coefficient of the phase equals whatever jerky thing equals floor. PLD, path length difference, now divided by the wavelength. Path length difference divided by the wavelength. I don't even know what that means. The phase remainder is the blank subtracted from absolute value of path length difference, wavelength ratio, blah, 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 blah. Well, anyway, I already went over all this crap. So, no, I won't assume he's an idiot, but I'm just saying the reason why we're using 90 degrees is because the center just creates a confusion. And it's obviously, it's fooled everybody. It fooled me until very recently, you know, a few weeks ago. I was fooled. I thought it made sense to say, hey, this one is the same length as this line. Therefore, it's a whole wavelength. Therefore, it has to be a maxima. I didn't realize this is 1 millimeter. Okay, this is nothing. This happens inside of 1 millimeter in here, right? I mean, this node is going to be 5 inches long, 5 inches in size. I can't even draw how big it's going to be proportionally. It's going to be this gigantic thing. And this is the only part this is creating. It's all inside of 1 millimeter. This is completely a lie. There's no node here, okay? There is a node. I'm just saying, just recognize, compared to the real nodes, this node is nothing. It's irrelevant. And the fact is this node can be anywhere. This node could be an off, and the new node starts here, and there's another node over here. Or these two nodes could be actually overlapping. You know, this one could be overlapping this one. And that's what you have here too. That's the reality. This isn't a real node. This is garbage. This is the real one. This is the one you can be guaranteed is correct. And then if you just build on that one, you'll get all the rest of them correct. So anyway, I don't know what any of that crap really meant. The path length difference at 90 degrees is the total distance between the surface and dictates what the node at 0 degrees will be. So I thought that was really clear. Clear enough. I mean, you have to have some knowledge of the geometry here. But I mean, it's what I just said. 90 degrees is reliable. It'll tell you what 0 degrees is. All right. He says this is confusing. So even though I've explained it, it's still confusing. At 90 degrees, we have a maxima path length difference. Exactly. It's the path length difference is the distance between the surfaces. The total distance between the surfaces is the path length difference. So it makes it really easy. That is the distance between the surface edges of the slit. If the path length difference is purely taken as a starting point, we can calculate all maximas and minima nodes in a spherical screen. Exactly. But they are not equidistant. Yes, they are. Why are you saying they're not equidistant? Who told you they're not equidistant? Who told you they change size? They're on a circle, essentially. Essentially, you're taking a piece of string. These 2 points are so close to each other that I might as well just take a piece of string from a center and then just move it around. Right? I mean, 2 pieces is, and just let the string roll on a little wheel. I mean, it's always going to be equidistant because there's no, it's so tiny. The distance between the slits is so tiny compared to the distance you're away. It's like why Einstein's math works, right? The precession of Mercury is because the sun is jiggling. And the Earth is so far away, it doesn't feel the jiggle. Alright, well, whatever. Let's see where this goes. We can calculate all maximum and minimum nodes in the spherical screen, but they are not equidistant. Well, again, I just totally disagree. And they don't need to start from the 90 degrees. They don't need to, but as I just pointed out, it's the most certain point you can start. It's a great point to start because it's so simple to calculate. You could start anywhere on the arc. I'm just saying this one just gives it away to you so simple. It tells you what it is, and now it's just adding 1, 2, 3, 4, 5, 6. You just count how many nodes away you want to go, and it's really easy to calculate. Nor any other degree. Let's see. They don't need to start from the 90 degrees, 0, or any other degree. Well, the point is that 90 degrees is unique because the 2 lines are on top of each other. So their path length difference is exactly the distance between the surfaces. It is a different than some other point. 45 degrees doesn't have that nice advantage. How would the phase off or phase on photon know which direction others are going? So that's not the point. The point is that your 2 lines are right on top of each other and there's no volume to your triangle. There's very unconfusing. Okay, the difference in the path length of the lines is so fucking simple to see. I would rather assume that all necessary information must be at the vectors A and B meeting point on C, carried with the additional phase and intensity factors. Well, I don't care what you rather, frankly. I'd rather not. I'd rather just say, once I know this one, I know them all. All right. We can get a normalized phase shift between 0 and 1 that oscillates up and down between on and off nodes. Well, whatever this baby talk is, about this oscillating word. It's a disgusting word, in my opinion, to be using in this conversation. It's just disgusting. There's nothing oscillating here. All right, you're either enough in phase to be a photon, or you're not enough in phase to be a photon. That's it. So we know there's some fudge factor because we know the central maxima, and we know the on nodes aren't just tiny little spots in space. We know they're kind of big. They bleed into, the off nodes. The idea is that the offs and the ons are the same size. But obviously visually when you look at it, they're not going to look the same size. But we're saying for the purpose of just establishing the center point of the node, that is the point that is on and the point that's full off. Full on, full off are 2 points. All right, they're just single points. So I could have full on here and full off here. What we are already assuming, what's assumed in this conversation, is that you're saying the node is actually, a distance around that center, and there would be a distance around this center. Now obviously when you do the experiment, you'll see that the node sizes end up being more like this. Okay, I mean the off nodes are a lot smaller than the on nodes. Okay, but we know that what we're representing is the center of the nodes. That's what the math is predicting, is the centers. Shit. Alright, with that, let's see. Off nodes, for example, with the equation 2abs, but whatever this is, any point on the screen, but doesn't matter from which direction you start counting the nodes. On off nodes are independent in a sense. Well, anything you're going to do where you're going to tell me it doesn't matter, distances don't matter, I'm going to say bullshit. So yes, if you want to just say, I'm just going to predict the very center of a node, and I'm not going to predict the size of the node, okay, yeah, you can do that arbitrarily. But that isn't what most people want out of the experiment, okay, is to tell them where's the center of the node. Don't tell me its orientation, don't tell me how big it is, just tell me where the center is. That's not telling you very much. Okay. Have you ever calculated... You really don't get the whole point of my channel, do you? I mean, the whole point of my channel is that the physical universe actually doesn't have to be calculated. You can actually draw a picture of it. Okay, it's actually physical objects in three-dimensional space. And you can even use a lot of one-dimensional drawings to illustrate exactly what it does. So no, I don't really sit around saying, what am I going to calculate today? I can't wait to do some calculating. It just never even occurs to me to even think about, what can I calculate today? Because it's the math. It isn't the universe. It's not the reality. The map isn't the territory. And we can just draw the territory. I don't need the math. All right. Have you ever calculated the point locations on the surface of the screen? I just pointed out to you how simple the calculation is. So, okay, once I know what happens at 90 degrees, I know what happens everywhere else. So I guess yes, I have. The distance between the on-off nodes is different and increasing, decreasing when the point C angle changes. No. It doesn't, okay? Because as long as you put them on this curved surface, they'll be exactly the same size. So I think you're wrong. So you have to show me somewhere where how a near perfect ellipse, okay, can create different pi sections. This can also be understood intuitively because every single degree increase would cause a greater difference in PLD. So again, there's no such thing, as you pointed out, there's no such thing as a starting point. I can make 90 degrees 0 degrees. I can turn this anywhere I want. Doesn't matter. So how could there possibly be a place where the nodes are bigger and a place where the nodes are smaller? It's not possible. It's only possible if you don't realize that the 1 millimeter of this distance between these two focuses creates an ellipse of infinitesimally small out of roundness. Okay. Radius would always be the same in a spherical screen. Yes. so you're conceding the point, thank you. But it's a vector, but it is vector lengths starting from both sides of the ergo. So I don't know, what the hell fuck is this ergo? That dictate the gradual increase decrease. Not when it's less than a millimeter compared to meters of distance. Okay? No, it isn't. So you can say that, but when the proportions are so gigantically disproportional, that is, the distance to the target is so much larger than the distance between the sources, you can't possibly make this argument that you're going to make different increments, because the ellipse is almost non-existent. It's so close to a perfect circle. Can be easily plotted on a coordinate system, but let us just focus on the nodes in the next part. Yeah, whatever. Anyway, locations of the nodes can be retrieved by solving the x-coordinate from this equation. So fuck you. I'm sorry, but fuck you. I've already figured it all out. I already have simple equations. I don't need any of this lambda and, you know, sine theta bullshitty nonsense. But anyway, is the wavelength of the light. Distance is the slit edge distance from the ergo. So again, you're doing this crazy distance horse shit, where you're creating an artificial half and then saying the distance is 2 halves. Well, duh. L is the radius of the circle, and pi is the whole number coefficient of the phase. Well, whatever that is. Pi, whatever this other jerky symbol is. Solving x gives us blah, 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 blah. Who cares? Put all whole number points from phase max to phase, whatever, blah, blah, blah. Let's just get out of this crap. Distance between blah, blah, unequal everywhere but in the middle of the screen. So, I don't know. Says you is all I'm going to say to that horse shit. You have to show me where there's an experiment showing it. I mean, Stephen Bro even, you know, he showed a double slit experiment where you could actually see probably, you know, visible small nodes, at least, let's say, 150. So you could see 150 little bars. And there was absolutely no visual indication they were substantially changing in size. Okay? No indication that they had different sizes. Alright, distance change is probably not visible in the first nodes, but certainly by math simulation it would be realized after several nodes. So you say so. So you say with a, if I made an ellipse where the focuses were, say, 40,000 times, the distance between the focuses was 40,000 times smaller than the distance to the edge of the ellipse, that somehow I would be able to see that, I'd be able to calculate that that change at that surface, at the ellipse. That somehow if I cut it into sections, that I would be actually able to see any change in the absolute distance. When you're talking about a millimeter to a mile, and you're saying that you're going to see that difference. So in the worst case scenario, that is at the widest part, it's 1 millimeter. So it's a mile, we have a mile pi, okay? It's a mile across. And I'm going to make a 1 millimeter change. So this length will be 1 millimeter shorter, and this length will be 1 millimeter longer. Okay, and you're going to tell me that, you know, you'll be able to see a difference in the sizes of footprints or something. Bullshit. In real experiment, we just have light intensity problem here on varying that. I don't know what that would mean. Alright, so first nodes, but certainly by math simulation it would be realizable after several nodes. So I'd say Prove it. Show me. Show me any single slit or double slit experiment. Spread out the widest one you can find, and on a curved screen, right? Obviously, on a flat screen, the outside ones are going to get bigger and bigger and bigger. But on a curved screen, they're not. Anyway, 5. Sorry, this is going on forever. But I warned you in the beginning of the video. This is just for, if you typed all this crap, I'm going to answer the crap. The equidistant vectors pointing to the center do not create real nodes, as they only span a tiny distance. Okay, so that's what I wrote. The distance between the two surfaces at the target. Real vectors move in the same left-right direction. Okay, so let's see what he says here. This is also something that I don't understand. I just don't know. It's 1 millimeter at the source. 1 millimeter. The whole slit experiment is a millimeter. The point is the only stuff that spreads with distance are the stuff moving at angles. Right? Do you understand that part? So that's the only stuff that can get bigger with distance. So it's really small here, it gets bigger, it gets bigger, it gets bigger. The nodes get bigger and bigger and bigger as they go further away. You understand that part? Well, the point is these two sources coming in can't get bigger. So they're still inside of 1 millimeter. They're not shooting out and then going in, okay? They're going in from 1 millimeter apart. They can't get any further away from each other. They can't create anything out here. They can only go inside that 1 millimeter. They can only travel inside of that 1 millimeter. So you don't understand that? That inside of 1 millimeter is not a node? It's not have anything to do with what's really happening? Alright. I mean, I've been over that one so many times, I just can't. Lines are pointing in, okay? That's inside of 1 millimeter. Now, yes, if they overshoot this way, well, then they're spreading again. Because then they'll be going the same way again, right? So the whole point is the lines have to go in the same direction. This line going this way, this line going this way. They're going in the same direction. When lines are not going in the same direction, those are the ones you don't pay any attention to, because those are front and fire diffraction. That's near field diffraction. That's going in diffraction. It doesn't amount to anything because it all happens on the microscopic scale. It doesn't have anything to do with reality, so to speak. Anyway, I just can't, I don't know how to make it, I don't know how to explain it any simpler than that. PLD in the vertical line from Origo, whatever, is 0. Path length difference is 0. Yes, inside of 1 millimeter. The node is maybe 5 centimeters in size. What's happening inside of this one tiny millimeter doesn't have anything to do with these gigantic nodes we're creating from the spreading fringes. Anyway, but the phase is on, yet in the center is overshadowed by the direct light in the phase coming through the center of the slit. So the laser goes through the center of the slit and it does spread. So the laser still does spread a little. So it's going to fill in anything that's missing in there. But the point is that yes, there's a little tiny bright inside of 1 millimeter. And then there's fringes, little tiny fringes. Okay, and then there's the laser light that's just going to blind all of that out anyway. The photons that never diffracted at all. That aren't diffracting in, not diffracting out. They're going straight through. So those are going to meet the ones that are diffracting in. Don't you understand? The ones diffracting in, the ones that go straight through are going to hit those. They're all going to hit the same space. They can't miss each other, so to speak. They can't miss hitting the same 1 millimeter of space. Anyway. I mean, people should be able to pick this up. Yet the center is overshadowed by the direct light in the phase coming through the center of the slit. The wider the slit is, the wider the central maxima is. Well, that's just wrong. So you're way off there. Way, way off. Way, way, way off. That's just so backward. Okay, the wider the slit is, the wider the central maxima is. Now it's just wrong. The wider the slit is, the more laser light going straight through. So the very, very center is not bigger, it's brighter. Okay? Big difference. It doesn't get any wider. Okay, and the underlying pattern would be unnoticeable. So, of course, the underlying pattern is wider than the spread of the laser. So it's really not a problem. So the center maxima based on PLD was it is real or not. Was it real or not? Would not have any visible effect anyway. Well, it has a visible effect in the sense that obviously if there are two nodes starting, you know, if your slit starting locations for each side are here, these are the starting points, 1 millimeter apart. These are the starting points, here and here, for what you might call this, you know, without the 1 millimeter of fake space. So these are the real space, and 1 millimeter of this 180 degrees is the dead space because it's being broken by this stuff. Alright, so we're really only talking about these nodes. Now, if these nodes did start here, let's say the first is here. Okay, that this is actually off. Alright? This is actually an off here. Okay, because the on is here. Alright, and the other on is here. Now, obviously, if this wasn't here, if this diffraction going to the center wasn't here, if I could somehow erase that, and I could erase the laser beam shining right on here, then this would be noticeable as an off. You'd see it as an off. This would be a visible off then. But it's not a visible off because of this light coming through. So that's why when you put the impediment in, all right, like the single impediment creates a subtly different pattern because you don't get this much direct light. But you're still getting this. You're still getting the bright center from these two equidistant points. But it's not as bright. But obviously the two slit negates it pretty well just because, yes, now you're blocking the most intense light. Now that's all you got to say, really. The envelope obviously has this double, okay? So that's the double being created right here. You have two nodes that are over here, and this ends up getting filled in with superfluous light, so it looks like one node, but it's really two nodes. Alright, center maxima based on real or not will not have visible effect anyway. Well, the situation might change when the real scale differences are used. Nanometers, wavelengths, micrometers, slits width, and many other meters of L distance. So I don't know, that's kind of a wishy-washy statement, but fine. Based on the above equations, screw that, I would expect that the phase of the light scattering from the slit edges to the center is always on. Well, again, I'll point out to you it's not enough light. It's a tiny, tiny, minuscule amount of light that is inside of that 1 millimeter going to that location at that focus. The rest of the light's going this way and this way. There's only a tiny amount that is in this one place in space inside of that 1 millimeter. All right. I know why we should start counting from the 9-degree angle. Well, you complained about it before, now you say you know why. Since we can calculate the phase shift at any point independently and rely on that. Yeah, so why did you write all this crap? When PLD divided by theta is n times theta, then we have a phase on. But it is interesting that the phase off, the PLD phase, is not 0. The PLD divided by lambda is not 0. I don't know, I mean 0 is sort of irrelevant because 0 would mean you don't have any wavelength difference. There's no slit. anyway, I guess that the proposition mentioned in the other video that would be energy and temperature changes available at those points is related to this fact. No, the fact that there's energy hitting everywhere equally because it's being scattered to all locations equally. So the energy is hitting all the locations equally. And all you're saying is there's photons that are reconstructed by the rules. They're photons. If they don't follow the rules, they're not photons. But there's the same exact amount of quanta of energy. Scattered bits. The number of scattered bullets hitting each location is the same. We're just talking about where the bullets are back in sequence. The right phase, the right frequency. Anyway, the big, and also polarization, which complicates this. The big question is, how would the light intensity decrease when the light hits the farther nodes? The big question is, how would the light's intensity decrease when the light hits the farther nodes? So obviously, on a curved screen, there's no farther nodes. There's just ones that had to be bent a higher angle. And the argument would be is that bending happens incrementally, and therefore you're less likely to be bent a lot and more likely to be bent a little. The simple geometric model does not seem to give insight into that. Whatever. Fuck you. It explains everything, in my opinion. And there's not a question it won't answer if you ask the question anything called the reasonable form. So I'm just saying there's nothing left here that's all that mysterious. We could use the phase remainder. I don't even know what that is for, frankly. The remainder is just pointing out that you're not a whole wavelength. To have a gradient change between the nodes. No, the gradient change between the nodes is a fact of the fact that we can't do the experiment precisely. I would argue that if you had truly precise surfaces, that is, you had atomic surfaces so perfect that there was no irregularity. See, an atom is big, right? So just think how big an atom is, right? It's atom's small, 0.5 of a nanometer, right? All right, so it's 0.5 of a nanometer. So just think how few atoms you need, and you're already like, you could have 3 or 5 or 10 atoms worth of nanometers out. So I'm just saying the location of these electrons can be, you could argue, 10 degrees in, 10 out. So you could end up being anywhere between 500 the wavelength to go from 500 would be your goal. You could be going anywhere from like 490, to 510. And that's being really conservative, based on just atomic irregularities on the surface. So that's one reason. The other reason why the photons themselves probably don't have to be perfect. The distance between the quanta doesn't have to be exactly 500 nanometers. One of them could be 499, and this one could be, 503. And it would just be an average, would tell you the color, right? So whatever the average was would be the number, the color. So there can be all kinds of irregularities there, and those irregularities, that is, the 499 distance is going to create a different diffraction than the other one. So you're mixing the parts again kind of irregularly, and so that's why. But I mean, theoretically, you could understand that there's only one place where it's perfectly in phase. It's only in one tiny location where the phase is absolutely perfect. And the rest of the node is being created by imperfect. So you could argue that if an ideal two-slit pattern would just be bands of light, bars, with a great deal of distance between them. The dark spaces would be much brighter than the light spaces. and there would just be a strict little band, almost like emission spectra, because those are perfect. Those are reliable because those are made by specific atoms with specific distances built into them. So they are very rigid. And that's why you only get a little tiny band, a little tiny band, a little tiny band. Where this pattern isn't as rigid. So the bands have turned into blobs. Alright, the nose, but it's not enough to explain away the diffraction pattern is fading fast on the screen. So again, the fading fast on the outskirts, I would argue, is because it's less likely to be bent a lot of degrees. It might be even impossible. It has to do with, like, say if you made the slits very thick, okay, so they're deep, all right, like you have to travel through 6 inches of slit. Well, then you could understand there could be lots of banging around, lots of stuff, and you get lots of pieces flying out at very extreme angles because they have lots of a chance to be deflected, to be scattered. But if it's very thin, like just a layer of soot, then maybe the idea of going at a high angle would be very unlikely because you don't hit enough electrons. I mean, the idea is each electron causes a kick. You know, so you get 10 degrees from one electron, 20 degrees from 2, 30 degrees from 4, you know, that kind of thing. That would explain why the pattern weakens on the fringes. All right. Modeling experiment with 2L length of string attached to 2-point sources and marked in wavelength increments. So let's see what happens here. If the above strategy based on PLD is used to determine the phase, the wavelength increments will not match the nodes. Okay, so says you. Instead, you would get further off, closer to 9-degree angle you get. And again, that's only if, you know, you were talking about something where you were actually doing it at human perspective. That is, your ellipse and your focus is, like say your distance between, like say mechanically I did on this board, and I put a point here. Okay, well, let's draw it. I put a point here, and I put a point here, and I put a string on it to a point here. All right? So my string is only 3 times the distance between these two focuses. Well, obviously, then I'm going to get huge distortion because I'm creating a hugely elliptical object. I'm creating something that looks very elliptical. It's going to be very oblong this way. Okay? It's going to be a very misshapen circle. But if I make this realistically, okay, 10 meters or 5 meters away, okay, like, you know, then this small distance will not create much of an ellipse at all. It'll be a very round circle. So there won't be any. They'll all be the same size for practical purposes. All right. So, I mean, it's this, you just have to keep arguing it, I guess. You have to just keep going over it and over it. All right. Get further off the closer to 9-degree angle you get. But it is possible that you have a different math at some subtle parts of the model that I'm unaware of. So it's not a different math. It's just understanding that the geometry changes substantially as I change the length of the distance. The meaning of the angle is irrelevant. It almost goes away with a large distance. And I haven't seen the videos and talks on the DraftSciencere channel. And I haven't yet got to the experimental evidence that the diffraction pattern, why are you saying that word, really obeys the PLD-based maxima and minima. That is a separate issue. Certainly none of us have the perfect experiment where some scientist does the experiment, actually measures everything really carefully. Yeah, we don't have any of that. All right, the double slit experiment. So I don't know why he cuts this down to just that title, but whatever. I'd be interested in making calculations for the 2-slit version of the single slit version. Math can be conformed, and if you can find experiments to verify that it gives relatively good approximations for the diffraction pattern. I just don't know how you escape it. Okay, the only way you can escape, okay, that it works, is to say that the math they're currently using can't work. Because realistically, it's doing exactly what I'm saying. It's realistically, the math is explicitly saying, pretty much, there's a number of wavelengths between the 2 points. And that means there's a number of vectors. Okay, and there's only that number. There's no more vectors. There's just the same number of vectors of constructive interference as there is wavelengths that fit in between here. There's just no way to get around that fact. So once you accept that fact, that the number of wavelengths that fit in here will have to be on here. There's no way to avoid it. There can only be this number. I can't draw 2 lines from these 2 points that are going to create, say if there was 13 here, I can't find a place where I can make a 14th. There's no 14th. I can only find 13 places. I can't find the 14th. I can't find a 15th. I can't find a 16th. It doesn't exist. So we already know, once you've accepted that fact, that the number of wavelengths in here is telling you exactly how many nodes there are over here. Once you've accepted that fact, all of this is over. There's no mystery anymore. It's over. It's over. All right, afterthoughts. I think there is. So I guess he says, I'd be interested in making calculations to confirm this. We can find experiments to verify that this gives relatively good approximations. Afterthoughts. I think there is. You think there's good experimental evidence? I don't think so. Some unnecessary complications in the suggested single-slit geometry model related to the real center node and 9-degree angle. Some unnecessary complications. So I don't know what you're saying there. It's not an unnecessary complication to point out that it's idiotic to say it's non-negotiable that there's a maxima at 0 degrees. Because there isn't. It is negotiable because that is an illusion. It only happens within 1 millimeter of space. It's not a diffraction pattern. It's not part of the diffracting pattern. It's not part of the pattern that's moving and getting bigger. It's part of the pattern that's getting smaller. Okay. Let's see. B. Error in conjecturing that the nodes would be equidistant. So again, you say so. There's no evidence that they wouldn't be equidistant. So show me something that makes sense. I see absolutely no reasoning that tells me they're not going to be equidistant. What's your reasoning for the fact that they're somehow unequally distant when all I have to say is the whole damn thing is a circle? And it doesn't matter where I start. I could start here, I could start here, I could start here. What do you mean they get different sizes? They don't get any different in size. That's just bullshit. Approximately would make more sense, but it is necessary for any sufficient argument. I don't even know what that means. It's a question. Approximately would make more sense, but it is necessary for any sufficient argument. I don't know what that means. All right, whatever this is. And excluding the light intensity issue from the model. I don't know what that is. Negligence on excluding the light intensity issue from the model. What exclusion? What are you fucking talking about? What issue? I don't know what the issue is. But overall concept of thinking particle trajectories and surface edges of the slit being the leading cause of the diffraction. Well, I think that's a minor part. But yes. And the interference pattern is still a solid idea and quite appealing to me for further study. You know. So he thinks he made a critique here that's so valid that, oh, somehow I wasn't going to be able to answer it, I guess, because he's already drawn conclusions. Frankly, you have nothing here. The central maxima is not going to be dictated by two interior diffracting beams of light. The real pattern is dictated by real vectors, and so if you drew the real vectors, okay, both going in the same direction, so right outside of that 1 millimeter, see if the vector's still on. And my argument to you is, I bet it's not. Okay, so I mean, half the time it's not going to be. I'd be interested to see the two-slit version of the calculation. So again, it's all the same calculation. Single slit, double slit, same calculation. All you're doing is combining an overlap. The two-slit is just two single-slit experiments. This one, the outside surfaces, and this one, the inside surfaces. It's just two slit patterns superimposed on each other. There's no double slit math. You do the single slit math for the surfaces, and then you just overlay the two patterns and say where they both line up. Where they're both on, there's a photon. Where with one of them's off, no photon. And if they're both off, really no photon. If they're both out of phase. I'd be interested to see two-slit version of the calculation. So there's no two-slit version. The two-slit is just a composite of two single-slit experiments. Actual measuring of the experiment and the comparison of the trigonometric d sine theta m whatever lambda, the wave function path integration methods, blah 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 blah. By the way, I replied to your earlier video with a great comment. Perhaps you didn't see it. With a giant comment. I thought I did. Didn't I? Did it again? You did another giant comment that I missed? Oh. The GeoGebra document mentioned in the comment is already outdated. I'm not too sure it means anything to me, but you should give a simulated indication, but it should give a simulated indication of the equation's presence in these notes. I don't know, more might come, so I don't know what this is, but I will look at it later, obviously. Alright, so I did my job, I read all that crap. So yeah, you didn't help me any here. Okay, so just forcing me to go over the same crap over and over. There's nothing I need to add to what I wrote, because what I wrote is accurate. You certainly didn't demonstrate anything I wrote to be incorrect, so I didn't get anything from it in that respect. So the issues that are going to be a little complicated, I mean, obviously I can only write it, you know, I mean, you can only say it so many ways that, you know, yeah, these two vectors are the same, but they're two vectors that aren't expanding in dimension. They're staying within 1 millimeter. So I mean, here I am making them look like, look, they're this big. They're inside of 1 millimeter, okay? They're not the definition of the pattern. They're an aberration. They're a fact, but not meaningful. Not relevant to the pattern you see. The pattern you see is entirely created by vectors going in the same direction. Two vectors going this way, two contributions going this way. The entire fringe pattern, that's what it's made out of. Pieces flying in the same direction. Pieces flying in the same direction. When pieces are flying in opposite directions, that's a fake. Okay. I mean, I don't know how to make it any simpler, but I'll work on it. So anyway, this has been a difficult video. So really, I'm very grateful that you're participating. I'm grateful that you're interested enough to write all of this crap. But there's something in our communication that's just kind of breaking down, because you're really just not getting, you can disagree and say you don't believe what I'm saying, but I'm just saying what I'm saying is solid. It's not bullshit. And I don't need any of your bullshit math. I can just draw it and see it. I could even draw it and measure it, frankly. I don't, So I don't need to construct a formalization that tells me what's going to happen. I can just construct the model. But anyway, whatever. Well, let's see how it goes. Like I said, I don't want to discourage you from participating, but it's no big deal. So what? I don't like it. Too bad. A lot of people don't like what I do, so it's just the way it is. It's too bad. Keep trying, and maybe I can understand why what you're doing is important to you. But I don't understand why it's important. I've already answered all the questions. I've solved the problem. The problem is solved. We don't, the substance, 95% of any meaningful question is in those 6 statements I made. The other, there's 5% more. Polarization really does complicate things, blah, 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 blah. But 95% of anything you could want to know is already settled. Alright, anyway. So, this has been a Draft Science video presentation. Yeah. If you watched it all, good for you. Maybe it's good for you. I don't know. Maybe it was time you could have better spent. It is redundant, right? We're just going over these minutiae details. But they are all kind of important, and it's all these little subtle things are important, blah, 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 blah. So it shouldn't be... so some of that has to happen, I imagine. I just don't think it should happen with somebody as smart as this guy is. I'm surprised he ain't getting it. So anyway, till the next time. I already said that, but I'll say it again.